Hello, this is section 4.2, Applications with Systems of Equations. I'll let you read through the steps used to set up a word problem. Part 1, Everyday Applications. Example 1. Geraldine has been offered positions by two insurance companies. The first company pays a salary of $12,000 plus a commission of $100 for each policy sold. The second pays a salary of $2,000 plus a commission of $50 for each policy sold. How many policies would need to be sold to make the total pay the same? So very similar to back in chapter 3, you're going to be setting up equations here. But since she's offered two options, we're going to have two equations. So the first equation, it would be y equals 12,000 plus 100x, because they get $100 for each policy sold. The second one would be y equals 20,000 plus 50x. And now, how many policies would need to be sold to make the total pay the same? That's equivalent to saying solve this system of equations. Well, here, both equations are already solved for y, so I'm going to do substitution. Substitute the first equation into the second equation. We get 12,000 plus 100x equals 20,000 plus 50x. Subtract 50x from both sides. Subtract 12,000 from both sides. We get 50x equals 8,000. Divide by 50, divide by 50, and we get x equals 160. So that means she would have to sell 160 policies each year for them to pay the same amount. Now, what's nice here, because if I were going to try to solve this graphically, I normally wouldn't go to 160 on the graph. But now that I know that I have to go that far, I can think of this graphically. So I know 160 is where they intersect. And it didn't ask me to figure out how much she would make. That I just know that's where it would make. So I'm going to just say whatever that answer is up there. So they intersect at that point. Well, the first equation, which I'll do in green, has a y-intercept of 12,000. So let's say 12,000 is right here, and then it goes through that point. And then the second one has a y-intercept of 20,000, and then it goes through that point. So I'm doing a very rough sketch here. For some reason. You know what? It's just going to be easier for me to just change where the point is. So there's the intersection point at 160. Okay. Now why, even though the question didn't ask it, why am I graphing it? Well, I can see, let's say I think I can sell more than 160 policies a year. Well, that means I would want to use the first option, because that's where the green line is above the red line. But let's say I don't think I can even sell the 160 policies a year. Well, then I probably would take the second option, because that's where the red line is above the green line. So even though this graph is not perfect, it gives me a graphical representation of when to choose which option. Example 2. Aaron spent 30 minutes on the rowing machine and 20 minutes lifting weights at the gym and burned 430 calories. During her next visit to the gym, she spent 50 minutes on the rowing machine and 10 minutes lifting weights and burned 600 calories. How many calories did she burn for each minute of the rowing machine, and how many calories did she burn for each minute of weightlifting? Well, I'm hoping you notice that we're going to have two variables. Um, let's call R the calories burned while rowing, and let's call W the calories burned while lifting weights. Well, then from the um, first day, or first visit, I should say, we get 30 times R plus 20 times W has to equal the total calories burned, which is 430. Then for the second visit, we get 50 R plus 10 W equals 600. And this is my system of equations, and I need to go about solving this. I'm going to do elimination. I'm going to take the second equation times -2. Then it becomes 30R plus 20W equals 430. Negative 100R minus 20W equals negative 1200. That becomes negative 70R. The W's cancel out. And, oh, forgot the negative sign there. That would become negative 770. Divide by negative 70. Divide by negative 70. R would equal 11. Now I'm just going to plug that back in to the first equation, and we get 30 times 11 plus 20W equals 430, which is 330 plus 20W equals 430. Subtract 330 from both sides. We get 20W equals 100. Divide by 20. Divide by 20. We get W equal to 5. So in other words, she burns 11 calories per hour, per minute on rowing, and 5 calories per minute by lifting weights. Part 2, geometry applications. Recall, two angles are complementary. If the sum of their angles is 90 degrees, and two angles are supplementary, if the sum of their angles is 180 degrees. The difference of two complementary angles is 20 degrees. Find the measures of the angles. Well, I have the first angle, which I'll call x. Then I have the second angle, which I will call y. The first thing I'm told is that these are complementary, so that means x plus y has to equal 90. The next thing I'm told is their difference, so x minus y is 20. So this gives me a system of equations. Well, this one is particularly useful to use elimination because the y's already match. I'm just going to add them together and get 2x equals 110. Divide by 2, divide by 2, and get x equals 55. Plug that into one of the equations. I'm going to plug it into the second one. So we get 55 plus y equals 90. So I'm going to plug it into the first one. And we get y is equal to 35. So our first angle was 55 degrees, and our second angle was 35 degrees. Mario wants to put a fence around the pool in his backyard. Since one side is adjacent to the house, he will only need to fence 3 sides. There are 2 long sides, and one shorter side is parallel to the house. he needs 150 feet of fencing to enclose the pool. The length of the long side is 10 feet less than twice the width. Find the length and width of the pool area to be enclosed. So we have the house. Then we have a fence off of the house with only 3 sides, and we're told the short side is parallel to the house. So that's the short side. And inside here, we have a pool. There we go. Let's call the long side Y and the short side X. So first of all, I know I need 150 feet of fencing to enclose the pool. So that means X plus 2Y has to equal 155. Next, we're told the length of the long side, so Y means equals, is 10 feet less than, so that means minus 10, twice the width, so that would be 2x. So this is our system of equations. Well, since our second equation is already solved for y, this one is set up quite nicely for substitution. So I'm going to take the second equation and substitute it into the first equation. So we get x plus 2 times 2x minus 10 equals 155. So we get x plus 4x minus 20 equals 155. Add 20 to both sides. We get 5x equals 175. Divide by 5 on both sides. And we get x equals 35 feet. Now I'm going to plug that into the second equation and get y equals 2 times 35 minus 10, which is 70 minus 10, which is 60. So that means the length is 60 feet and the width would be 35 feet. And that's it for this first part of the video.